Have you ever stopped to think about Wi-Fi? It feels invisible, almost like magic, but it powers nearly everything we do in our digital lives. Our phones, our laptops, our smart homes, even our offices and the cloud services we rely on every single day. But Wi-Fi didn't just appear out of nowhere, fully formed. It evolved, step by step, through a series of technical standards. So today, let's pull back the curtain and explore the fascinating evolution of Wi-Fi. From the very first wireless networks, all the way to the futuristic speed of Wi-Fi 7. So, what exactly is Wi-Fi? It's not just a brand name you see on a router box. At its core, Wi-Fi is a family of wireless networking standards, all defined by a group called the IEEE 802.11 Working Group. Think of them as the architects of our wireless world. With each new standard they release, they're pushing the boundaries, improving speed, extending range, and boosting the overall efficiency and reliability of our connections. Each new number and letter you see, like 802.11n or 802.11 AC, represents a new chapter in this story. Our journey begins back in 1997 with the original 802.11 standard. This was the big bang for wireless local area networking. It operated on the 2.4 GHz band and offered a top speed of just 2 megabits per second. By today's standards, that's incredibly slow. The connection wasn't always stable, but it was revolutionary. For the first time, we could connect to a network without plugging in a cable. It was the proof of concept that started it all. Just 2 years later, in 1999, things got interesting with the arrival of two competing standards, 802.11b and 802.11a. 802.11b also used the 2.4 GHz band, but it cranked the speed up to 11 megabits per second. It had great range, but that 2.4 GHz band was getting crowded with things like cordless phones and microwaves, which caused a lot of interference. Meanwhile, 802.11a took a different approach. It jumped to the cleaner 5 GHz band and offered a much faster 54 megabits per second. The trade-off: its range was shorter. This created the very first split in the Wi-Fi world, forcing consumers to choose. Did they want better range or faster speed? This split didn't last long. In 2003, the world was introduced to 802.11 grams. This was the standard that really brought Wi-Fi into the mainstream. It was the perfect compromise. It operated on the popular 2.4 GHz band, giving it the excellent range of 802.11b. But it also delivered the impressive 54 megabit per second speed of 802.11a. It was the best of both worlds. With 802.11 grams, Wi-Fi became affordable, fast enough for most people's needs, and started appearing in coffee shops, airports, and homes everywhere. Then, in 2009, we saw a massive leap forward with 802.11n, which would later be known as Wi-Fi 4. This standard was a game changer. It introduced a technology called MIMO, which stands for multiple input, multiple output. In simple terms, it allowed routers to use multiple antennas to send and receive data simultaneously. This dramatically increased speeds with a theoretical maximum of 600 megabits per second. It could also operate on both the 2.4 and 5 GHz bands at the same time. MIMO didn't just boost speed, it also made connections far more reliable and robust. The need for speed continued, and in 2013, 802.11ac, or Wi-Fi 5, arrived. This standard focused exclusively on the 5 GHz band to avoid congestion. It introduced wider data channels, allowing more information to be sent at once, and smarter antenna technology called beamforming. Beamforming lets the router focus its signal directly toward your connected devices instead of just broadcasting it in all directions. This resulted in a stronger, more stable connection and a massive jump in theoretical speeds, all the way up to 6.9 gigabits per second. Suddenly, streaming multiple HD videos and competitive online gaming over Wi-Fi became a smooth, lag-free experience. By the time 802.11ax, better known as Wi-Fi 6, launched around 2019, the conversation started to change. It wasn't just about raw speed anymore. The real challenge was performance in crowded environments. Think of an apartment building, a stadium, or even a modern smart home with dozens of connected devices. Wi-Fi 6 was designed for this reality. It introduced key technologies like OFDMA and improved MUMA, which allow a router to communicate with many devices at the same time much more efficiently. So while the top speed of 9.6 gigabits per second is impressive, the real magic of Wi-Fi 6 is how it reduces lag and improves performance for everyone in a congested area. The later edition of Wi-Fi 6E also opened up the brand new 6 GHz band, providing a superhighway for compatible devices. And that brings us to the present and the very near future, 802.11b or Wi-Fi 7. This is the next giant leap. We're talking theoretical speeds of up to 46 gigabits per second. But again, it's about more than just speed. Wi-Fi 7 introduces a groundbreaking feature called multi-link operation, or MLO. This allows a single device to connect to the router using multiple bands like 5 and 6 GHz at the same time. This increases speed, dramatically reduces latency, and makes the connection incredibly resilient. If one band has interference, the other can pick up the slack instantly. Wi-Fi 7 is being built for the demands of tomorrow: immersive, augmented, and virtual reality, cloud gaming, and other real-time applications that require an ultra-fast, ultra-reliable, and ultra-latency connection. So why does Wi-Fi keep evolving like this? The answer is simple: because our digital lives keep evolving. Every year, we have more devices connecting to our networks. We're consuming more data than ever before, from 4K and 8K video streaming to massive game downloads. And we're using more real-time applications that are incredibly sensitive to lag. Our demand for faster, more reliable wireless connectivity is relentless. And so, the evolution of Wi-Fi must be relentless too, from a humble to megabits per second to the multi-gigabit speeds of today. Wi-Fi has quietly grown to become one of the most essential technologies on the planet. It's the invisible thread that weaves our modern world together. And as we've seen, the next evolution, bringing even more speed and capability, is already on its way. Thanks for watching. If you found this interesting, don't forget to like and subscribe for more tech deep dives.